Hello, Eric the ITGS Guru here, and today we're going to be talking about communicating on a network. Communicating on a network. In order to send and receive data on a computer network, there needs to be a way of identifying both the sender and the receiver. The following production will discuss the different options. MAC addresses. A MAC, or Media Access Control Address, is a unique number built into virtually every network device. Unlike IP addresses, which can be shared in some cases, each MAC address is unique. Typically, MAC addresses are stored in a device's ROM, since they are not designed to be changed. For this reason, a MAC address is sometimes called a hardware address. MAC addresses filtering is sometimes used on wireless networks to prevent access by unauthorized devices. However, although designed to be unique and permanent, it is relatively easy for a competent user to change or spoof their MAC address. Protocols. A protocol is a set of rules about how to do something. Communication on a network could not occur without networking protocols. Different protocols are used for different types of communication. Internet protocols. The Internet Protocol, or IP, governs how devices on a network are identified and how information is routed between them. Despite its name, the Internet Protocol is used on many networks, not just on the Internet. On an IP network, each machine is assigned an IP address, which uniquely identifies it on that network. An IP address contains 4 groups of digits separated by dots, such as the number shown below. An IP address can be configured manually on each computer on the network, but in order to avoid addresses conflicts where 2 or more devices have the same IP address, addresses are normally assigned to computers by a DHCP, a Dynamic Host Control Protocol server, which keeps track of the addresses it has assigned. Private addresses. With millions and millions of computers in the world, each one cannot have a unique IP address. Therefore, the IP protocol features private addresses, which are only used by computers on private networks, such as LANs. Transmission Control Protocol. The Transmission Control Protocol, or TCP, is the father half of one of the most common network protocols, TCP/IP. While the IP protocol deals with the addressing of individual devices and routing data between them, TCP deals with ensuring that data is sent and received correctly. If a packet of data is lost in the network due to an error, TCP is in charge of making a request for the data to be resent. How are IP addresses assigned? When your router connects to the Internet, it is assigned an IP address by your ISP. This may change each time you connect, which would be a dynamic IP address, or it may remain the same, which is a static IP address. But how does your ISP know which IP address is assigned to you? All IP addresses are managed by IANA, the International Assigned Numbers Authority. IANA assigns blocks of IP addresses to different geographical regions. When you connect to your ISP, it assigns you one of the IP addresses from its allocation. A side effect of this assignment is that a user's location can be deduced from their IP addresses. Since a record exists of which IP addresses are assigned to which geographical regions and TSP, the geolocation has implications for privacy, which is an ethical issue. Ports. Ports identify the services available on network computers. For example, when connecting to a web server to retrieve a web page, your computer will connect to port 80, because that is a standard port used for HTTP protocol. And here in the diagram below, you can see a nice diagram of how a firewall is used and the different ports and how they communicate with the Internet. The future of IP addresses. The current IP addressing system technically called IPv4, uses 32-bit addresses, meaning there is a total of around 3.4 billion possible IP addresses, which may seem like a lot. According to the International Assigned Numbers Authority, there were 150 million unassigned addresses remaining in September 2010, which isn't a lot if you consider there's 4.3 billion total. New addresses are being assigned at a rate of 243 million a year, so it's projected that they will quickly run out of IP addresses. The solution to this is adoption of a new standard, the IPv6. IPv6 uses 128-bit addresses, given a total of 2,128, 4.3 times 1,038 addresses, easily enough for the foreseeable future. Here's a bibliography and a useful source for finding out more information about IP addresses and ports. And around here at Eric the ITGS Guru, we close with, stay nerdy, my friends.